Hello and welcome to Labs and Latte. This is a show about diving into the NRA Labs curriculum while sipping on our favorite bean-based beverages. So grab a coffee and let's get started. And we've got a great episode lined up today. This is the 5th episode in our version control with Git series. There's probably going to be one more. I have one more planned, and then maybe we'll look at some other subjects. But today we're going to be starting to get into a topic that I think is really important if you're going to start learning about using Git either professionally or for your personal projects, and that is the idea of Git remotes. Now, before I get into Git remotes, I do want to mention a little bit of a perspective here. If you haven't seen any of the earlier episodes, I highly advise that you go back and watch them and maybe go through some of the lesson content. The reason for that is up until now, we've been really only focusing on what I like to call Git fundamentals. These are concepts like working with staging, so moving files into and out of staging in a Git repository, in a local Git repository, committing those changes so that you have a record of what's changed and by who and at what time, things like that. Working with Git branches and merging and doing things like that, checking things out. All of these are under an umbrella that I like to call Git fundamentals. I call them that because mostly they're going to be with you no matter what. You'll find that Git is actually a very robust tool, and there are a lot of things about Git, and as well as a lot of the other software that's built on top of Git that we'll get into shortly, that is actually very different based on what project you're working on and what environment you're in. And if you're working with Git professionally, even what company you're a part of. But Git fundamentals are much more core, I think, to the experience. You're always going to be making commits, you're always going to be moving files in and out of staging, and you're always going to be working with branches. Now, though, as we start to get into this topic of Git remotes, we start to really broaden the scope of what we're talking about. There are a lot of things that we'll talk about today and in the next episode that are actually a little bit different from project to project. I'll try to call those things out as I come across them. But just FYI, starting really now, roughly, this is when we start to get into some of the things that may vary based on project, from project to project. I'll try to keep things as close to the core fundamentals as I can, but just understand that starting now, we're going to start to look at some things that might have a little bit of variability based on where you're using those tools. So with that, if you haven't grabbed a coffee, please do so, and let's dive into Git remotes. So here we are in part 5 of this lesson, and as always, if you'd like to follow along, which I encourage you to do, the lesson, the link to this particular part of the lesson will be in the video description below, so navigate down and click on that if you'd like to follow along with me. And so Git remotes, we've thus far really only been working with a local repository. In the first 4 parts of not only this lesson, but all these different videos that I've recorded on this subject, we've only been working really with our own local repository. And naturally, this is where people start using Git. Really, the use case here is I've got a bunch of files that I really just need basic version control on. There's absolutely nothing wrong with using a local repository. However, in practice, in my experience, it's fairly uncommon for it to stop there. Unless it's a really temporary project, or if it's just sort of versioning maybe some simple configuration files that you just want to keep track of, it's pretty rare to work with Git in only a local capacity. Generally speaking, if you're using Git, you also want to use it to collaborate with other people. Now, in the last 4 parts, we've kind of been faking it. We've had some sort of scripts behind the scenes that make it seem like other people are contributing, but it's really been just us. Where we use Git remotes is actually where we expose, or we start to get into that environment where we actually can collaborate with other people. Because the idea of using a Git remote is saying, look, there's a version of my own Git repository that exists somewhere else, somewhere out on another server, or maybe across the internet. And what I would like to do is either push my changes that I've made locally to that remote, or pull changes that I know are there on that remote repository, pull them into my repository. So you can kind of think of them as 2 different copies of the same repository. Now, the visual I have here in the lesson guide is probably a really good way of looking at this. This is certainly not the only way that Git remotes can work, but it's a very popular one. And you'll find that a lot of what I have in this lesson is based on what is common in practice, not necessarily what's always going to be true for you in your particular scenario. But this is a pretty common way of looking at it. If you are trying to use Git to collaborate with others, you're all probably going to have a copy of the repository. But what you need is a version of that repository or yet another copy that's sitting out there that everybody can access. Generally, this is some server. Like if you're within a company, a lot of companies have their own internal Git servers, and these could run any number of pieces of software that I'll get into shortly. And this is another very common thing, you could use a platform like GitHub or GitLab or any number of hosted services that offer Git repositories that exist sort of on the internet. And what this does is it allows a bunch of different distributed people to have their own copies of the repository, but then there's a sort of neutral middle ground, so to speak, where the sort of the golden copy of that repository is located. And the idea is what you can do is you can make changes in your local repository and then push those changes to the remote repository so that other people can see what you've done. And that way they don't have to have access to your laptop. You all can sort of meet in the middle in this public repository. Now, this brings me to the next point that I'd like to be pretty clear on. A lot of people, when they get started with Git, they get hung up on something, which is that Git and GitHub kind of sound like they're the same thing, and they're absolutely not. Git is not the same thing as GitHub. You can kind of think of Git as really pointing to a lot of the fundamentals that I've talked about thus far. In fact, in the previous 4 parts, I haven't brought up GitHub at all or used GitHub at all. GitHub is a hosted service that takes the core fundamentals of Git, all the things that we've learned about and more, and what they do is they actually build value on top of that. And they do a pretty good job of it, in my opinion. They have a lot of really cool tools for collaborating using Git, but in a more streamlined capacity, especially for open source. So things like issues or pull requests, projects. Now they have actions for doing things like running serverless functions within GitHub. All of these things are specific to that platform and are not core to Git itself. And you're going to find that I try to do as best I can to use the terms appropriately. When I mean Git fundamentals, I'll say Git. When you hear me using the term Git, I'm really only talking about those fundamentals, the concept of staging and commits and branches and all that kind of stuff. When I say GitHub, what I'm talking about are the services that GitHub adds on top of those core Git fundamentals. Now, the benefit of using a platform like GitHub is actually multifaceted. Again, they use the core fundamentals of Git. So if you want to use things like ingesting commits and things like that, they're built around that. But they also add a lot of value on top. So if you want to collaborate with an open source project, the idea of using a pull request is part of that. We're going to get to that in the next part. Using issues and projects, they do a lot of really cool stuff. But I want to be clear about the difference between the two, because this is a frankly, when I am helping people understand Git, I run into this. Oh my goodness, so many times people get hung up on the difference between Git and GitHub. So yeah, just be aware that the two things are not the same. GitHub is really built on top of Git and offers a lot more that is not part of the Git experience that we've been looking at thus far. The experience we've been looking at thus far is really mostly only about the fundamentals. Okay, now that that's out of the way, let's get started with this lesson. This lesson is actually pretty simple. What we're really only going to do now is become accustomed to the idea of using remotes. We really won't be going into too much detail. The lesson, this part of the lesson really only focuses on the bare minimum of what you need to get started with using remotes in general, because there's a few setup related things that we need to make sure are taken care of. And the first thing is authentication. Again, if you're using a service like GitHub, you're probably going to have some sort of a user account that you're going to need to set up. And when you're contributing to a repository that's located within GitHub, you need to be able to authenticate to that service. GitHub needs to know, hey, this person's trying to push all these commits to me. Who is this, and do they have access to do what they're trying to do? So the way that we do that is we authenticate using either, if we're using HTTP, that's a transport protocol that you can use with Git, in which case you would provide, I believe, basic authentication, or maybe they use a token system now. I actually don't use that because the other transport that you can use is SSH, which I find to be much, frankly, easier to use, and it's also more secure. And you can also use, when I have two-factor authentication on my GitHub account, and this is compatible with that. So I find SSH to be a better transport protocol to use in general. Obviously, if you would like to use HTTP, that's your prerogative, but this lesson guide is going to use SSH as an option. So in order to do this, the very, very first thing we need to do is actually generate an SSH key. What this is going to do is it's going to create a public and private key pair that we're going to use to tell our Git Remote, hey, this is the SSH key that we would like to use to authenticate to you. So we got to generate that key first. And you can click this handy run the snippet button, and it's going to copy that command over here into the Linux One terminal. There's no output to that, but I can just show you what happened. It's going to generate a private and public key pair. The public key is what we actually need. So let's cat the contents of that. And you can see that the contents here, everything from SSH-RSA, all the way down here to the first instance of antidote at linux.1. Be careful not to include this. This is not part of the key. This is just the next, the bash prompt itself. So make sure you don't include that. Copy all the way up to here and all the way back to SSH-RSA. Make sure that that's highlighted. You can then copy this to your clipboard by hitting Control-Insert. And now that that's in our clipboard, the next step is to navigate over to our remote. Now, a quick aside on this as well. The software that you're looking at right now is called Git. This is designed to really look very similar to GitHub, but it's not GitHub. I just want to be clear about that. It's designed to look very similar to GitHub, and I included it in this lesson to make it pretty close to the experience that you would get if you were using GitHub. Just know it's going to be a little different. It's going to be pretty close, but it's a little different. There are some very minor differences. In general, though, what you should do, if you do want to use something like GitHub, you should already have created a user account, and then once you have an account, you can kind of pick up here. Because just like in what we're going to do here with Git, you'll still have to do the same thing we're doing with GitHub. So let's sign in as our user, and again, in this case, we've already created a user account, but in GitHub, you should create your own. So password is password1 exclamation point. Let's get rid of that. So you can see there's really nothing here. What we need to do is we need to add the SSH key to our profile. What this does is it tells our Git Remote software that whenever we send a request using this SSH public key, that we are authenticated properly and that we're authenticated as this Jane user. So to do that, you go down, go to this drop down and click Settings. Go over to SSH GPG keys. Next to Manage SSH keys, you click Add key. Just skip the key name because it's going to get filled in for us automatically, and paste the contents of your clipboard, which is what we copied from the last step, into this content field. And then just simply add key. The UI in GitHub specifically is a little different, but otherwise the process is exactly the same. You go to your profile, there's a section on SSH keys, and you add your SSH key there. So cool. What this means is the SSH key that we've generated in the Linux One terminal in this container is now added to our account, and we can now use it to authenticate to our Git Remote software. So this brings us to the first use case, which is pushing a repository you already have to a remote. And this is, like I said before, this is actually not a very uncommon use case. It's not that uncommon to just want to work with Git locally, sort of off the bat. Maybe you just have some simple config files that you'd like to apply some version control logic to. I mean, we all have these directories on our laptops that's got some important config files in them, and it would be nice if we could, track the changes that we've made to them so that if we make a mistake, we can go back maybe weeks later and make sure that we store the differences between them. That's not uncommon. Like I said, though, in my experience, you're usually going to get to the point where you want to push that push that repository to a remote, if only for the concept of just backing it up. Maybe you just want to have a remote copy of this repository so that if your laptop gets bricked, you still have a copy of it somewhere else. And that's totally fine. Maybe also you may say, hey, I've had this local repository for locally for a while, and I'd like other people to at least see it. That way they can see what I'm working on, so the boss doesn't ask questions about what's on my plate. Maybe that's another use case. Like I said, inevitably there's gonna be a situation where you're gonna want to push the contents of your repository to a remote repository. And that's the use case that I'd like to tackle in this lesson. In the next video, by the way, we're going to get way more complicated with this. So this will be a sort of a simple use case, and then we're going to build on what we learned today in the next video with a much more, I think, complex and useful use case. So for now, let's just focus on getting the repository that we've been working with this whole time, this repository, my first repo, that we've been working with for 4 videos now. And in this video, we'll concentrate on pushing that local repository to the Git Remote that we just authenticated to. So the first step is we need to create a home for this repository. Right now, the remote has no knowledge of this repository whatsoever. The only instance of this repository is located in this my first repo directory that we've been working with all along. And you can see this is here, right? All of those commits are still here. Right now, this is the only place this repository is located. So what we have to do, if we want to push this somewhere, we have to create a placeholder for it. We have to create the repository itself. So we go to New Repository in this dropdown, and let's name it My First Repo. You can see there's a dropdown just ready for us, which is nice. My First Repo. Now let's just leave everything else blank. And the main reason for that, really, well, first off, we really don't need to populate any of these. You can if you'd like. I wouldn't make it private. You can fill in a description if you want. I would leave everything else blank. The really important thing that you should leave blank is this checkbox here. The reason for that is, and this is, by the way, GitHub has the exact same option. If you create a repository, it gives you this option for initializing the repository. Let me just be real clear about what this option actually does. If we were to check this, what this actually does is it creates the repository and then it automatically adds a commit of its own. It automatically makes a commit that includes these files that it's saying, the .gitignore, the license, and the readme. And normally that would actually be great because it sort of bootstraps our repository. It allows us the opportunity to make the repository have at least something in it. However, in our case, this is actually a problem because we've already been making commits of our own. And if we were to check this box, it would create a commit, a root commit, that is incompatible with the ancestry that we already have. We wouldn't be able to push the commits that we have without doing some crazy magic. So what we actually want to do is uncheck this and create a totally blank repository that has exactly 0 commits. And the reason, again, for that is we have our own commits that we intend to push, so let's just create a blank repository for now. Click Create Repository, and you can see you go to this next screen. Now, you'll see here, as mentioned before, there are 2 transport options for working with Git remotes. You can push over HTTP, or you can use SSH as a transport. And if you navigate between the two, really this doesn't do anything other than just changing some of these helper commands that I'll talk about shortly. But let's just highlight SSH so that everything becomes pretty clear. You'll see the URL here. We'll reference this in a little bit, and we'll break down everything inside of this URL. You also note that we have 2 sort of code snippets that are provided here for us to run based on what we're trying to do. If we don't have an existing repository, we can use these commands. But since we have an existing repository, we actually want to use these commands, because what this does is says, okay, well, you already have your own commits, so I'm not going to bother adding commits here. What I'm going to do is actually just allow you to create a reference to this remote and push what you already have, which is exactly what we want. Okay, so let's scroll down and we'll go to the next step. And in the snippet you see here in the lesson guide, you see I actually have copied the command that's straight from this example. So we're actually going to run that. But before I actually run that, let me explain what it does. We're already in the My First Repo directory, so we don't need to run that. But let me break down this Git Remote command, because this is a little new. It's a subcommand. We've been working with the Git command this whole time, but the Git Remote subcommand is new. Anytime we are working with making changes to remotes, we're going to be using the Git Remote command. What this does is it's actually a helper command on top of git config. Remember, all the way back in part 1, we worked with git config. The Git Remote command allows us to make changes to the configuration, but specifically for working with Git remotes. So we're going to use this command to add a reference to the Git Remote that we just set up, and that'll allow us to use another subcommand, namely Git Push, to then push the commits we already have to this Git Remote. A little bit of a sort of a word soup, but fortunately, what we're about to do, we only need to do once. We only need to add the Git Remote configuration once, and then from there, we just need to push and pull. That's it. So Git Remote, again, allows us to add a reference to our remote. As you might imagine, the next command is the word add, because again, we're adding a reference to this remote. Next keyword rather, is we're going to type origin. Now, technically, you can put whatever you want here. This is really a human-readable label for the remote here locally. We're going to be actually referencing this label in the next command that we run. So we do want to make sure we use a name that's reasonable. We don't want it to be super long. Some people even use much crazier and shorter names for their remotes because they just want to, save keystrokes. We're going to use origin mostly because this is an overwhelmingly common convention. There are a lot of other commands, for instance, git clone, if you're cloning one of the repositories that exist remotely to your local file system, that uses this as the default. And so as a result, origin is just a very popular convention for naming remotes. So I would recommend that we stick with that, and that's what we're going to do for now. In the next version in the next video, by the way, we're going to be playing with this a little bit, but for now we'll just keep it simple. Git remote add origin. So we're saying I want to add a reference to a remote, and I want that reference to be named origin so that I can use that reference in future commands. Now, the last parameter for this command is that URL we saw earlier. This is a URL for using the Git protocol specifically. And by using this, we're going to be using the SSH transport. Now, if you wanted to use an HTTP transport, the URL here would be totally different. It would use HTTP, obviously, at the beginning, or probably HTTPS, and then the format would be a little bit different after that. But since we want to use SSH, let's start with Git. This is the username that we're forwarding to the remote. This is pretty popular, actually, for most Git remotes that use SSH. GitHub works the same way. You're not actually authenticating as the Git user. Your authentication is actually being done by the SSH key we set up before. So what we're doing here is we're just saying the user Git is what we're using in this particular sort of protocol that we're setting up here. But we're still authenticating as the Jane user by virtue of our SSH key. So just keep that in mind. Next is the host name. Now, again, if you're using GitHub, this is probably going to be github.com. But in our case, our Git server, the server that's running our remote software, is actually located at the host name remote. And we can even access it if we wanted to ping the host name remote. We could. So yeah, we'll just use the hostname remote. Again, if you're using GitHub, this will be github.com. If you're using GitLab, I think it's gitlab.com. So yeah, this will vary based on what kind of software you're using. But again, in our case, in this lesson, the hostname is remote. From there, we type a colon. And here is from now, it's just the path to the repository. You can think of it kind of like a path on a website. So we say like Jane is our username, or this is where our repository is located, and then the name of the repository itself, myfirstrepo.git. And we click enter, and you can see using git remote -v, you can see that we now have a reference to the remote we named origin, and it even includes the URL for fetching commits as well as pushing, which is cool. Now, I also want to mention, as I mentioned before, Git Remote is also is basically a helper command on top of Git config. So this actually does modify our Git config. So if we list the Git config options, you can see that our Git config has been augmented with these options. So the URL that we've added is right here, and the name origin is also added as an option there. So yeah, it's turtles all the way down. Okay, rubber meets the road. We've added a reference to the remote, but we haven't actually pushed anything to our remote repository. And you can see this by clicking again on my first repo, nothing has changed. So let's push our changes, and that way we can actually see some stuff here in the web UI. If we do git push, and we type -u, and then the origin, or the name of the remote, again, is origin. So we're saying I want to push to this remote, and we reference it by name. So we set up the remote first, and then we're referencing it by the name origin. And then we specify the git ref, or really the reference to the thing that we want to push. This could be any number of things, by the way. But in this case, what we're doing is we're pushing the master branch. So we just type master. Now, there's a whole bunch of output to this. You can see that the very first bit of output is actually from SSH itself, saying, hey, I've added this IP address and this host name to the list of known hosts, and that way, going forward, we recognize it. And then there's a whole bunch of other things that show sort of the difference in what we've pushed versus what the server has received. And then finally, we show the new branch that's created, because what it's telling us is, hey, the master branch actually didn't exist until now. And so we're letting basically the server is letting the client know that it was created, which is kind of cool. And if we go back to the remote branch, we can then click on my first repo, and now that all that helper text is gone, and we can see the contents of our repository. And this simply contains the interface-config.txt file that we've been working with this whole time. And you can even click on it and see its contents. You can also see the commits tab. So if you wanted to see all the commits that we've made, this is a nice graphical representation. All of the the commit IDs are represented here. You can click on them or the commit message to see the actual commit and the changes that were made here. This is Fred sort of interacting with our repository that we saw before. So yeah, that's pretty cool. Now, the last thing I want to show, we've pushed commits to the remote. Let's figure out a way to pull or fetch commits from the remote repository to our local repository. So if somebody were to make a change, say, to the remote repository, we can then incorporate those changes back to our repository. Again, this is a common example. Like, there are some open source projects that have people integrating their changes, maybe hundreds or even thousands of times every day. And we need to be able to constantly be able to pull those changes down to our local repository so that we can make sure we're working with the most recent version. And the way that we do that is we've used the git push command. Now let's use the git pull command. Before we do that, let's generate a change so that we can actually pull something. Right now, our local repository is actually at the same version of as our remote repository. So in order to pull something, we need to make a change. Now, again, normally this would be done by somebody else, but let's simulate this by just making a change of our own. The cool thing about remote software like this, as well as GitHub offers the same feature, is you can actually make changes to files right here in the web UI. I wouldn't necessarily rely on it for complex changes because it's not a full-blown IDE. It doesn't have any sort of like linting or anything like that. But for simple changes, it can be quite handy. So we'll just edit this file real quick and make a quick change the IP address to something silly like that. You can see that you can make your own commit message right here in the web UI. You also have an option to commit directly to the master branch. You'll see an option here that says create a new branch and start a pull request. You know about branches, but we haven't actually covered pull requests yet. That's something we'll cover in the next video. So for now, let's just commit directly to the master branch. Cool. So if we go back to the commits tab, you can see it actually created a commit for us 3 seconds ago. The commit message, the default one anyway, is update interface-config.txt. And it's built off of the last commit. But if we were to go back to Linux 1, you can see if we do git log, not gotlog, git log, you can see that the current latest commit is this 9D94665, which is this commit. So there is now a commit in the remote repository that we don't have locally, and we need to make sure we pull that down. As you might expect, that uses the git pull command. Now again, we've already specified the remote. We've already set up that reference to origin. We don't have to do that again. We simply refer to it here in the git pull command. And again, we specify the branch that we would like to fetch. And you can see we've moved from the head was previously pointing to that 99 commit, and now we're pointing at E531BF0. You can see that that's now, yes, that's the latest commit that I should have. Oops, didn't mean to navigate out of that. And now we can type git log one more time, and you can see that we now have that latest commit. And if we cat interface-config.txt, you can see the change is here. So yeah, we've actually pushed and pulled commits to and from our remote, and now we're set up to do much more complicated things. So this is a pretty light intro to Git remotes, but I think this is really necessary to really level set and get us started working with Git remotes, because we're going to be building on a lot of what we just did in the next lesson, which talks about things like how do I contribute to a project that I don't own, for instance. That's another very common use case. For this use case, we're just dealing with a repository that we control. But if you're using Git maybe to contribute to an open source project that is in a repository that you don't control, how do you do that? We're going to be diving into that in the next part of the lesson, as well as in the next video. So stay tuned, and we'll be covering that in the next few weeks. In the meantime, thanks for watching, and please give a like and subscribe if you'd like to see more of this content. Thank you.